Hey there. Today in lesson 8, we are going to talk about which variable to solve for. We've talked about variables and what they represent. We have talked about variables and constraints that can be put on them, like they have to be positive, they have to be whole numbers, etc. We've talked about constants, which never change. So whenever you have an equation and you have a lot of letters in it, those are all variables. And which one do we want to solve for? So let's get moving. That was weird. You see that big arrow? Let's rearrange equations to pin down a certain quantity. All right, so this table shows the relationship between the base length B and the area A of some parallelograms. And if you remember, area equals base times height. All the parallelograms have the same height. Hold on. That was my beginning of E-block alarm. Sorry. So here we have all the parallelograms have the same height. Base length is measured in inches and area is measured in square inches. Complete the table. So they all have the same height, and base length is measured in inches and area is measured in square inches. So let's complete the table. If I have base of 1, my area is 3. Okay, so area equals base times height. Here, my base is 2, my area is 6. Area equals base times height. So if I solve this one for height, divide both sides by 1, here my height is 3. Ooh, sorry, I grabbed my head. Let's do this. Okay, I'm pausing to erase. I don't know why erasing is so hard. Let's do this again. So area equals base times height. So 3 equals 1 times height. So what is the height in this? All right. Height equals 3. All right, so area equals base times height. What's the height on this one? 3. Area equals base times height. What's the height here? 3. Area equals base times height. We know the height, so let's just do 4.5 times 3. Area equals 11/2 times height. Height is still 3. 33/2, which equals 16.5. Then here I've got area equals base times height. Well, we know the height is 3, so what times 3 equals 36? 12. And then area, 46.5 equals base times height. So if I know height is 3, what times 3 equals 46.5? Okay, I just divided this by 3. 46.5 divided by 3 is 15.5. Nice work. Good warm-up. All right. So let's decide whether each equation could represent the relationship between B and A. Be prepared to explain your reasoning. Decide whether each equation can represent the relationship between B and A. We had A equals base times height, And we knew that height was 3 for all of them. So I could say that, I like the number first, etc. So area times 3 equals base does not work. And we could just grab one of these values up here. If I do that first one, base is 1, area is 3. If the base is 1 and the area is 3, is that an equivalent equation? Nope. All right. So here we can say, we can even test base is 1, area is 3 on all of them. But here we know area equals 3 times base. So here I've divided both sides by 3, and I have the right equation. Look, these are all A. Isn't that funny? So that one is correct, I believe. So let's try it. Let's substitute 1 for B and 3 for A. 1 equals 1. It works. How about A equals B over 3? Well, that's different than what we have right here, so that one doesn't work. But let's test just to make sure. 3 equals B is 1 over 3. Those are not equal. And then here I have area equals 3 times B. Area is 3, and B is 1. Those do equal each other. Good job. All right, are the two equations we chose equivalent? How do you know? We chose B equals A over 3 and A equals 3B. Yes, they are. I can do algebraic moves like multiply both sides by 3 to get them to look alike, or divide both sides by 3 to get them to look alike. So look alike, or I can substitute a known solution. Either one. If we know the base, which equation would make it easier to find the area? If we know the base, I would plug it into area equals 3 times base. Because if we know the base, we're going to substitute here and get an answer for area without moving anything around. If we know the area, which equation would make it easier to find the base? Base equals area, divide by 3. If we know the area, we'd plug it in right there, and we get a solution that would give us the base. All right. Post-parade cleanup. Okay, it's our second activity in the lesson. After a parade, a group of volunteers is helping to pick up the trash along a 2-mile stretch of road. So a group of volunteers, a 2-mile stretch of road. The group decides to divide the length of the road so that each volunteer is responsible for cleaning up equal lengths of sections. So we have a length of road, excuse me, and we're dividing it up for each volunteer. So N would be the number of volunteers. Right? Okay, so we'd be dividing that road up along so many volunteers. So find the length of a road section for each volunteer if there are the following number of volunteers. Okay, be prepared to explain or show your reasoning. We haven't talked about a variable yet, so let's look at it. Sorry. Oh, 2 miles. Silly me. So be prepared, find a length of road section. So I can say the length of road section equals 2 miles over 8. Would be 1/4 of a mile per person. All right, I took the number of miles of the road and divided it by the number of volunteers. So my length of road is equal to 2 miles over 10, or 0.2 miles per person. Okay, my length of road is 2 over 25. I'm not going to simplify that because it doesn't simplify pretty. Miles per person. Now I'm adding 1 to the miles with each one. M, M-I, M-I-L. It's like we're playing pig with our math. Length of road is 2 miles over 36 volunteers. I can simplify that to 1 over 18, and that would be miles per person. Okay? So that's the length of road for each volunteer if they're the following number of volunteers. After a parade, same thing. So now we're going to write an equation that would make it easy to find L, the length of road, if there are n number of volunteers. So we did L equals length of full length over the number of volunteers. I shouldn't use length again. Yeah, total length of road. So we did the work, but let's come up with an equation now. So length of road section and miles for each volunteer. So little l equals 2 over n, right? I'm going to go up here and fix what I did. Okay, we need this to be little l. Okay. And then we're going to find the number of volunteers in the group if each volunteer cleans up a section of the following lengths. So little l equals 2 over n. Now we're going to find the number of volunteers if each one cleans up that much section of road. So really, if I do, I'm going to go ahead and probably answer this question. This will probably be a future question in the lesson, but I need to solve this equation for n because now I want to find the number of volunteers if I'm given a length of road. So I have n times l equals 2. I can divide each side by little l, and I'm left with n equals 2 over little l. And that's what I'm going to use here. So the number of volunteers equals 2 over 0.4. And that equals 5. Okay, the number of volunteers equals 2 over 2/7. And that equals 7. Oh, I didn't have to. The number of volunteers is 2 over 0.125. And that equals 16. 16 volunteers. I should write the answer. And n equals 2 over 6/45. 15. So we rearranged our equation to make our work easier. So write an equation that would make it easy. We already did the length of road equals 2 over n. So I'll do it again. I need to solve this equation for n. So I have n times l equals 2, and then divide both sides by l. N equals 2 over l gives us the number of volunteers. We rearranged the equation to make our work easier. We rearranged it once and we could use it every time. All right, let's try another one. Tank A initially contained 124 liters of water. It is then filled with more water at a constant rate of 9 liters per minute. So initially contained 124 liters, and then it's filled, which is a plus, at a constant rate of 9 liters per minute. How many liters of water are in tank A after the following amounts of time have passed? So if we've got 9 liters per minute and I have 4 minutes, that's going to be 36 liters, and add that to the original. 160 liters. 80 seconds. Okay, this is liters per minute, so I don't know how many seconds, 80 seconds is how many minutes. So I'm going to do 80 seconds. And I know there's 60 seconds. I don't know why I said 16. 60 seconds in 1 minute. And that gives me 2/3, 4/3 of a minute. So I'm going to take that 4/3 of a minute and multiply it by 9 liters per minute. And I get 12. 12 liters. Add that to 124, and I have 136 plus 124 equals 136. In M minutes, we're just going to do 9 times M plus 124 equals total liters. So it's really neat how we take, the book has been doing a great job of like starting with something simple, making it a little bit harder, and then coming up with the equation. Right? We've done that quite a bit. So how many, and this was using the equation, excuse me, total liters equals 9 times your minutes, 9 liters per minute, plus your initial amount. Now we're going to look at how many minutes have passed when tank A contains the following amount of water. So I'm going to solve this equation for M, all right? I'm going to do T equals 120, I think we did 9M, plus 124. So if I subtract 124 from both sides, I have T minus 124 equals 9M. Divide both sides by 9. And that is M equals T minus 124 over 9. That's the equation we're going to use. And just plug in what we know. Okay, this is my total amount. So I'm going to plug it in, 151 minus 124, divide by 9. And I get 3. So 3 minutes. 151 minus, nope, 191.5 minus 124. Take that and divide by 9. And you get 22.5 minutes. Okay, we have even more, so our time should get higher. 270.25 minus 124, and then divide that by 9. Minus 124, divide by 9. 16. I made a mistake here. If you are working along with me, you would have seen it. I divided by 3 instead of 9. It was just a miss. I didn't push the right buttons with my calculator. But how did I know I did it wrong? Because with this one, when I had more liters in the tank, then B, my time was less, and I should have more time. Okay, now P liters. It would be P minus 124 over 9 equals M. Okay, that's the equation that we would use. How do you know that the expression gives us the liters of water in tank A after M minutes? Because we solved the equation for M, right? As simple as that. We solved the equation for M. How do you know that the expression gives us the minutes at which the tank reaches P liters? I looked at the units. the units I'm left with, if we had, in the equation, we had the liters in the tank minus the liters in the tank divided by 9 liters per minute. Okay? And that all like liters cancels out and I'm left with minutes. So I know that my answer is going to be in minutes because the units work out that way. All right, suppose a classmate who is absent today wanted to know, what does it mean to solve for a variable? Okay, why should we solve for a variable? This one, what's it mean? So we isolate the variable we're trying to solve for. Isolate a variable. That's what I think of it. I'd love to hear what you guys think. And then why should we solve for a variable? Because it's easier. It is easier when you solve for a variable. Mathematicians are a tad bit lazy. I'm a tad bit lazy when it comes to math. I always look for the easiest way to do something. And how do we solve for a variable? We isolate that variable. We do PEMDAS backwards. If you notice, we always, when we're solving for a variable, we do addition and subtraction first, then we do multiplication and division, then we do parentheses and exponents. We go backwards. And how would you respond to these questions? We just did. All right, your learning targets. Given an equation, I can now solve for a particular variable, like height, time, or length, when the equation would be more useful in that form. I know the meaning of the phrase to solve for a variable, okay? Solving for variables, when you have, I know in your homework you've done density equals mass divided by volume. When you just have letters, it can be so much harder to figure it out. Like if I want to solve for m, I will circle m and I'll say v is currently in the division spot. So what's the opposite of division? Multiplication. And what I do to one side of the equal sign, I have to do to the other. I'm supposed to cross that out. So mass equals density times volume, right? If I do this another way, density equals mass over volume. If I'm trying to solve for volume, I still have to move things around. I need volume on the ground floor. It's currently in the basement. So if I multiply both sides by V, I'm left with V equals D times M, but I did that wrong. V times D equals M, but I'm trying to solve for V, so I need to get rid of the D. So now divide both sides by D. Well, volume equals mass divided by density. Sometimes it is so much harder when you're dealing with just letters, but if you treat them like the numbers and move them around with your allowed algebraic moves, you'll be good. Okay, and the same vocabulary word. Good job.